Hello and welcome to my science tutorials. In today's video we are going to be looking at motions up and down an inclined plane. If you are new to my science tutorials, kindly consider subscribing and pressing that notification button so that you don't miss any of our latest tutorials on biology, chemistry, mathematics and physics. Alright, so in today's video, like I said earlier on, we want to look at motions up and down an inclined plane. So let's start with this diagram. Okay, so assuming we have a plane inclined to a horizontal surface at a particular angle theta, okay, then we throw a body up this plane, up or down the plane. Okay, if we throw a body either up or down the plane, gravity will act on the body. Now the gravity acting down on the body, okay, has two components that we need to take into consideration when we want to do any calculation on this particular diagram. That is, gravity acts downwards. So for instance, the gravity that will act downward on this body will act downward like this. But then we have to look at what the horizontal and then the vertical component of this body moving either up or down the inclined plane. That is, the gravity, the perpendicular component of this gravity will act in this direction, and then the vertical or the component along the plane will either act downward or what, upward, depending on whether the body is going up or down. So if the body is what, let's start with the perpendicular component. The perpendicular component of this particular body will be given to us by what? G cos theta. Now the component acting along the plane is what? G sin theta. Now because this, if the body is coming downwards, that is a downward motion. So gravity is what? Also acting down, so it is in favor of what? Gravity. So the gravity takes a positive sign. But then if the body is moving up the plane, the gravity takes what? Negative G sin theta. Now based on these components of the diagram that we have over here, because our body is moving along an inclined plane, we have a slightly different version of the motions of what? Of motion under gravity. Sorry. So a normal motion under gravity, we have V is equal to what? U plus what? GT. Then we have V squared is equal to U squared plus what? 2GH. Then we have H is equal to what? UT plus half GT squared. Now in this example, or under this topic, the gravity is no longer the normal gravity that is acting downwards, because the body is moving at an angle to a plane. So we need to consider those factors. Now the body is moving along this plane, not the horizontal plane, so we are not going to use the cos component of this diagram. So we are only going to be using the sine component. Now the sine component also depends on whether the body is moving up or downwards. So what do I mean? For the equations of this diagram moving upward, that is, it is moving in this direction upward. Let me use green for that. So it is moving upward, so it means what? It is acting against what? Gravity. So gravity is what? Negative. So for those ones, the equations will change slightly, and then we have V is equal to what? U minus, then the gravity will now be what? G sin theta. Mind you, the negative over here is what we have over here, then we multiply it with the t. Then the second equation will become what? This is equal to this minus what? 2 into bracket, the gravity will be what? G sin theta what? H. Okay, so the final one will be what? H is equal to what? UT minus what? Half G sin theta t squared. So this is for what? Motions what? Upward motion along the inclined plane. So what of what? Downward. when the body is what, coming downwards. Okay, so when the body is coming downwards, the only difference is what, this, the negative sign over here will not become positive, and that is the only difference. So we have what, v is equal to u plus what, g sine theta t. Then we have v squared is equal to what, u squared plus 2g sine theta h. Then we have what, h is equal to what, ut minus what, half, oh sorry, plus half g sine theta t squared. So this is the components that we need to take into consideration when we are looking at what, a body moving an inclined plane. So let's have a look at an example. Example number 1. A body which was on an inclined plane made an angle of what, 45 to the horizontal, moved from rest along the plane for 10 seconds. Find its final velocity and the distance traveled after 10 seconds period. So beautiful. Let's write our solution. Okay, so let's try to visualize what the question is telling us. So the question is saying a body which was on an inclined plane made an angle of what, 45 to the horizontal. So it means our plane makes an angle of what, 45 degrees to the horizontal, and then we have our body on it. Okay, so and moved, let me see, to the horizontal, moved from rest along the plane for 10 seconds. Now if they are saying is it moved along the plane, okay, this is an inclined plane. A body placed over here cannot move along this plane, so it means the body has to be placed at the top for it to be able to move downwards along the plane. So this is what, a downward motion of this body along the plane. So it means the gravity is what, positive. So it's what, g sine theta. All right, so now that we know this, to find our final velocity we use the formula what, v is equal to u plus what, g sine theta t. Okay, so the time given to us in this question is what, 10 seconds. Okay, so we just substitute that, but because this is now like a downward motion, our what, initial velocity is what, 0 meters per second. We need to take note of that as a fact. So we have what, our v is equal to, the initial velocity is 0, then the gravity we are being given to be what, we are using the gravity to be what, 10 meters per second squared. So we have what, 10 sine theta, which is 45, and then t, the time is what, also 10. So this is technically 100 sine 45. And then if we punch this into the calculator, we are going to get 70.07 meters per second as the final velocity of this body moving down the plane. Now we have to find the final velocity, which is what we've calculated, and then the distance traveled. So the distance traveled over here, okay, is what, more like our height, okay, or s. So we use what, s for the distance traveled. S is equal to, or it's more like the height, is equal to ut plus what, half g sine theta what, t squared. All right, so s is equal to, our initial velocity we already know is 0, so it will nullify all of these things. So we have half g is 10 sine 45, then we have our time is what, 10 squared. So it means everything we have over here is equal to what, 353.55 meters. So it means the distance along the plane that the body moved downward is what, 353.55 meters. Let's have a look at another example. Example number 2. A ball is thrown up a smooth inclined plane with initial velocity of what, 54 kilometers per hour. If the inclination of the plane is what, 30 degrees, find I, the time taken for the object to reach its maximum height, and then I, the maximum height reached, given that gravity is equal to what? 10 meters per second squared. So let's go ahead and write our solution. Let's draw what we have. So we have a ball is thrown up a plane. So we have, this is our plane with an angle of what? 30 to the horizontal. Then we have a body being thrown up the plane. So it means our component to be what? Negative g sine theta. Okay, so we have initial velocity is equal to what? 54 kilometers per hour. So which means our final velocity is equal to 0, because what? The motion is what? An upward motion. So first of all, before we even think of doing anything, let's convert the initial velocity into what? Meters per second, because that is the standard unit for measuring velocity. So this will be equal to what? 54 kilo is what? Times 10 raised to the power 3, then meters per hour means the hour will be down over here. Now 1 hour is what? 60 seconds times what? 60 minutes. So this is what? 54,000 divided by what? 3,600. So it means our initial velocity for this particular example is what? 15 meters per second. Okay, so now that we have our initial velocity, let's go ahead and find what? The time taken to reach the maximum height. Alright, so from v is equal to u minus what? G sine theta t. Okay, we know our what? Final velocity is equal to 0, so it means g sine theta t is equal to u. So our t is u divided by what? G sine theta. So our time is equal to what? Our what? Initial velocity, which is what? 15 divided by what? 10 sine 30. Okay, so if we input this into the calculator, we are going to get what? 3 seconds. So it means the time it took this body to reach the maximum height is what? Just 3 seconds. All right, let's look at the second aspect, the maximum height reached by this body. So our maximum height, h max, is equal to what? Ut minus what? Half g sine theta t squared. Okay, so our h max is equal to what? Our initial velocity is what? 15. Our time is what? 3. Then minus half. Our gravity is what? 10 sine 30. Then our time is what? 3 again squared. So our maximum height is given to us by, if we input everything over here into the calculator, we are going to get what? 22.5 meters. So it means the body took what? The maximum height the body was able to reach, or the maximum height for this particular example is what? 22.5 meters. So this is just the only thing different from what? Motion on an inclined plane to motions what? Freely under what? Gravity. So the only difference is, instead of just using the gravity, you use the gravity sine the angle that the inclined plane was able to make with the horizontal to calculate to solve your problem. So thank you so much for watching, and then if you are new to my science tutorial, like I said in the beginning of this video, kindly consider subscribing and pressing that notification button so that you stay informed when we upload a new video. Thank you so much for watching, and I will see you in the next video. Bye bye.